we talked about more ionic bonding and relationships with that. And so this is what we're going to do. I'm going to write on the board a formula. And then what we're going to do with that formula is we're going to go through a process.
Okay, so just to show you this, because you had to sign it. Mr. Dungan had to sign it.
We're going to go through a process to draw this formula out, and we'll end up with a molecule and how it's structured and put together. Alright? So, I'm going to go ahead in the upper right hand corner, you guys can do it on your paper too. I'm going to go ahead and give you a formula, and it's going to be NClH2. So that's not Ci, but Cl. Okay? The first thing I'd like you to do, based upon what we did yesterday, is to draw each symbol out, and then draw the number of valence electrons that would be around that symbol. And you guys remember what valence electrons were? Where are they located? Outer shell. So electrons in the outer shell. So to get the number of valence electrons, if you remember, we counted across on the periodic table. We counted across from, like, for example, we're doing nitrogen first. So we count across, lithium starting with lithium, so we go lithium's 1, beryllium's 2, boron's 3, carbon's 4, nitrogen's 5. So that's what we do, is we show that and write it out for question number 1, or statement number 1. Okay, you do. Now, if there's 2 hydrogens, you separate those 2 hydrogens and you do them separate. Okay? So there's nitrogen, you do the other 3. After you do the first step, where you draw them out, each separately, second step I want you to do is to count all your valence electrons. So if you're following along on this sheet of paper, it goes step by step what you need to do to draw this structure out to be successful. So number 2, you count all the electrons that are around each of the atoms and you add them all up. When you do these counts, you'll always get an even number. So every time you count on all of these that we do, you end up with an even number of electrons. Because what has to happen, we have to have each electron being in a pair. And that means that they'll be paired up as 2, 4, 6, 8, depending upon how many you have. An even number, so when I count all the electrons up, I can end up with 11. If I do, I give you the wrong information, or you counted wrong, or you did your dot notation wrong. Even number, for example, this one is 14, right?
There's 5 dots.
I'm sorry, would be 12, right? Count them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, there are 14. 14 electrons. Okay? So we have 14 electrons. I want you to read statement number 3. And then pick out what you think the central atom would be after you read statement number 3. I'll go ahead and read it out loud. I'm recording this, so I'll probably have to read it out loud. Number 3, it says, find the element that has a dot notation that requires the most electrons to get an octet of electrons. That means 8. You'll never pick hydrogen, because hydrogen will be, it only needs 2 to have a full shell. Every other gas, every other nonmetal will have to have 8. Reading on, it says, write the symbol down and then surround this symbol with each of the other symbols that are drawn out. Do not include any dots at this time. So don't use any dots in your drawing at this time. Okay? So which one will we choose to put in the middle? Nitrogen. Okay? Austin, you get this? Does everybody see why nitrogen is in the middle? It has 5. Okay, it has 5, and it needs 3 more electrons to get 8. Where chlorine only needs 1, and hydrogen only needs 1, to where they will have 8. So the more electrons it needs, the more likely it's going to be in the central atom. Okay, everything else is going to be branched off. Questions? All right. Number 4 reads, place a pair of electrons in between the central atom and the outer atoms, or the branched atoms. So what you're going to do is you're going to just place one pair in between the central atom and each of the branched atoms, like that. And then we keep track of our electrons as we put them in our Lewis dot structure. So we're forming our Lewis dot structure. And as we do that, we kind of keep track of our electrons here. The reason I put 6 there is just a mental calculation or physical calculation I can do. And I'm left with 8 electrons left over. I have to use all the electrons up. So if you say, well, I'm done, you're not done. Because I've got to use all 8 electrons in my structure. Any questions? All right, number 5. If we've got any electrons left over, we need to place those electrons around the branched atoms. So branched atoms would be like the chlorine, the hydrogen, or the 2 hydrogens. That's what we're going to have to put all the electrons around if we need to. Now, hydrogen, we won't include any more electrons. I said hydrogen is a branched atom, but hydrogen is complete with the 2 electrons. You don't add any more to hydrogen. Hydrogen is complete after it has its 2. Everything else has to have 8. So I'm going to take the branched atom of chlorine and I'm going to put 6 or 3 pairs of electrons around chlorine. So now does chlorine have 8? Okay, so we're okay there. I've taken 6 away from 8 because right now I started out with 14. I'm showing 2, 4, 6, 8, 10, 12. Okay, I'm showing 12 and I started with 14. Does anybody have an idea? Yeah, it goes off nitrogen because it only has 6, right? So nitrogen only has 6. So that central atom, that says that in its statement there, that if you get to this point and you haven't used them all and you've got all the branched atoms taken care of, what you need to do is put it around the central atom to get it to where it has 8. So now we have 14 electrons. This, what we have here, is called the Lewis dot structure. Okay, I want to simplify it. I want to make it a little cleaner than showing all those pairs of electrons because it can get really, looks messy when you get a bunch of them going in there, especially branched atoms that have to have more than, 2 electrons. So what I'm going to do is I'm going to clean it up a little bit, and I'll show what it looks like. What it looks like if we just have lines drawn. Okay? This is what it would look if we had lines drawn. Does that look better? Okay? Now, I'm not including any electrons around any of the branched atoms. I'm just showing lines. It cleans it up a lot. Have you guys seen these lines before, right? Yeah, and that's called the structural formula. And you have dealt with structural formulas when we did alkanes. Alright? So, for this to really work, you have to do one example, and then we'll kind of stop you after maybe a couple steps to see if you did those couple steps right, and walk you through it, and then we'll see what the final outcome is if you kind of understand each of the steps and how they work. Okay? So I'm going to go ahead and give you one to transition through to see if you can walk through it and get the answer right. So we're going to go C, we're going to go F2, H2. So you'll have to draw 2 fluorines, 2 hydrogens, 1 carbon. You need to go step 1, 2, 3, 4, 5. Let's do the first 2 steps, and then I will stop you, and then we'll continue on. So what you have for 1 and 2? Alright, we're on our way, 1 and 2. So then 3, you pick out the one of those ones that are listed and choose which one you need to put in the middle based upon the statement. It is the one that needs the most electrons added in its outer shell to get 8. And that one goes in the middle and everything else surrounds it. Okay, it's the central atom. Pick out the central atom. Which one is it? C. Yeah, C. C, senor. Okay? Yes, ma'am.
Does it matter like what order we're going?
It doesn't matter. The H's could be across from each other, and the F's could be across from each other. They can be at any position around the central atoms as long as you're showing 2 of them, 2 F's, and 2 H's around it. It does not, because when we do the 3-dimensional view of it, like we did isomers, no matter how you turn it, it's going to be the same. Okay? So the next thing we do, you guys go ahead and do step number 4. Do step 4. So we have 20 electrons. Step 4 says you need to place a pair of electrons between the central atom and the branched atoms. When we do that, we get 8 electrons taken away from the 20 original electrons. We're left with 14. Now, what do we need to do with some of those 14? Oh, my subtraction is bad. You guys didn't even catch me on that, did you? 12 electrons. Okay? 12 electrons. Sorry. Yep. So now hydrogen does not require any more electrons. It's only fluorine that requires.
So then do we do 3 on 1?
Yep, 3 pairs on one and 3 pairs on the other, and then we're out of electrons, right? And our structure is done, at least our Lewis Dodge structure. That's really messy. I mean, when you look at that, it's just like, it's kind of tough to figure out what's going on. But we've counted them all. There's 20. Everything has 8 electrons around it, except for hydrogen. Carbon, 2, 4, 6, 8. Fluorine, 2, 4, 6, 8. They all have 8. And that's what we want. When we're done with our structure, everything is required to have a full shell. For hydrogen, that's 2. For fluorine, that's 8. So then we need to clean it up. And to clean it up, it's a lot better. Okay? Now the reason we're doing it in this way, we could probably get away with, for me showing you a different way. Tomorrow when we get into double and triple bonds, it's a little bit more difficult to show. And that's what we'll do. Tomorrow is number 6. As number 6, what will happen is we'll end up with not everything having 8 electrons around it, and everything has to fulfill the octet rule. And so we do this thing called double and triple bonds to get everything to have 8. They share extra pairs. Okay? So what I want you to do for tomorrow is practice these steps with the following compounds. PFH2, CBr2, H2, ClF2N2 or N, and then Cl2O. Now what I would suggest before you go, so you don't have to use the periodic table, is just kind of leave a fair amount of space, maybe do it on one page, and then top quarter is the first one, middle quarter, second and third, bottom quarters, the last one, and then just draw your dot notations for each one before you leave. Then you can follow the steps, and you don't have to have a periodic table. So you may want to just do all your dot notations for every molecule, 1 through 4, and then you don't need your periodic table anymore. You can do everything from that. So why don't you do that? For tomorrow, we'll look at these. I'll come around for a completion grade. Have it done, you get 10 points. If you don't, have half of it done. I don't know if I can give you 5 points or not, but you wouldn't get the full complement of points. Okay?